Chapter 7, Section 1, Reduced Mode. When the robot enters reduced mode, the velocity, momentum, and power of the robot will be limited. Reduced mode can be triggered by a safety input signal or safety plane. When using a safety input signal, the robot enters reduced mode when one of the signals is low. After the condition for triggering reduced mode is configured, the parameter for reduced mode can be adjusted in robot limits. The limiting parameter can be changed by selecting from presets or be customized manually. The range and velocity of each joint can be adjusted in joint limits. After applying the changes, the robot will be automatically powered off. Users need to power the robot back on manually. If the robot is currently outside of the movable range, the robot will enter recovery mode for users to adjust the robot pose. Section 2, Safety Plane. The location and the orientation of a safety plane is set by a frame. The positive Z direction of the chosen frame will be the front of the safety plane. The opposite side is the back side. Go to Safety Plane. Choose the configured frame. The restrictions can be applied to normal mode, reduced mode, or both. It can also be configured to trigger reduced mode when the robot crosses the safety plane from the front. By checking Restrict Elbow, Joint 3 will be limited by the safety plane as well. After applying the changes, the robot will automatically power off. Users need to power the robot back on manually. Check the result. Section 3, Safety Tool. By default, the safety plane only detects the flange and joint 3 if Restrict Elbow is checked. To make the end effector detectable by the safety plane, the safety tool needs to be configured as well. To make it simple, configuring the safety tool involves making a virtual sphere that can cover the end effector. When the safety plane detects this virtual sphere, it will trigger the configured safety action. The center of the virtual sphere needs to be configured by the TCP. The location of the center normally can be measured out. After configuring the TCP, enter the safety tool. Add a new safety tool. For tools with simple shapes, the radius generally needs to only slightly exceed the distance from the center point to the flange. After saving, the robot will automatically power off. Users will need to power it back on manually. If the robot is using multiple end effectors at the same time, or the end effector is fairly wide, using two safety tools can offer better coverage. Section 4, Collision Detection. The CS robot has a collision detection function. When the robot is running, if it detects a force exceeding the configured range, the robot will automatically stop. In the Configuration tab, go to Force Control and turn the collision detection on. A smaller min detectable force ratio causes the robot to become more sensitive to the force. If the ratio is set too low, the chance of misreporting a collision will go up, which might affect the normal use of the robot. Please adjust the force ratio based on the actual application.